Good evening all. Now I am going to explain about from the signal flow graph I need to find out state transition matrix. Okay, or state space analysis representation. Now see here, this is R of S is input, right? That input is equals to assume x1. That means this node as x1. Okay, then before this node is, this is x1, right? Then this node as x1 dot. Okay, next this node as x2 dot. This node as x3 dot. Okay, now see here, this x1 dot is having how many incoming nodes? That means how many incoming paths? Only one, right? That means if it is having only one incoming path, that is from forward path, then x1 dot is equals to, directly you can write x2. Okay, x1 dot is equals to x2. Similarly, x2 dot is also having only one incoming node, then directly I can write x2 dot is equals to here x3 dot, right? That means this parameter will be only x3, right? x1 dot is equals to x2 when it is having only one incoming path, x2 dot is equals to x3. Next see here, x3 dot. Okay, x3 dot is having 1 2 3 4 incoming paths, right? Then x3 dot is equals to, now see here, this is x1, right? Minus 6 x1. Next x minus 4 x1 dot, already we know that x1 dot is equals to x2, right? That is minus 4 x2. Next minus 2 x3 dot is equals to minus 2 x2 dot, already x2 dot is equals to x3, right? That is minus 2 x3. All these are minus values, right? After that 2 into u of s, that is 2 into u. Okay, x1 dot, x2 dot and x3 dot is completed, right? Next, what is the y of s here? R of s, right? Okay, that R of s is equals to x1, right? Now the matrix will be x1 dot, x2 dot, x3 dot is equals to, x1 dot value is only x2, right? That is 0 1 0. x2 dot is only x3, that is 0 0 1. x3 dot is equals to minus 6 x1 minus 4 x2 minus 2 x3, right? x1 x2 x3, right? Plus b into u, right? U term is having only x3 dot, right? That is x1 value is 0, x2 value is 0, b value is here, it is 2 into u, right? Here output is nothing but R of s, right? Then I can represent it, output y is equals to R of s value, how much? x1, right? 3 1 0 0 x1 x2 x3, y is equals to only x1, right? Okay, in this way, from the given signal flow graph we can find out the x dot is equals to ax plus b into y equals to c x matrix form. Okay, clear, right? Next we will discuss about compensators and controllers. Okay, first one is proportional controller. Now see here, proportional controller is represented by kp. Okay, then controller input gc of s is equals to kp. Okay, the purpose of this proportional controller, it is used to vary the transient response of a system. Okay, next integral controller. Okay, gc of s is equals to ki by s. Okay, that means 1 by s, right? Here pole is added to the open loop transfer function, right? That means when pole is added to the open loop transfer function means type increases, right? As a type of the system is increases, then it decreases steady state error. Okay, that means by using this integral controller, steady state error is reduced. Next, derivative controller, gc of s is nothing but kd into s. Okay, that means this s is represented on numerator side. numerator is nothing but 0. 0 is added. Poles and zeros already you know, right? 0 is added to the open loop transfer function, right? Okay, when 0 is added to the open loop transfer function, it increases the stability of the system. Okay, here stability is increases, but steady state error is also increases. Okay, that is about derivative controller. Now we can combine this proportional plus integral and proportional plus derivative controller. That is gc of s is equals to kp plus ki by s. Okay, if I take kp as common, 1 plus 1 by ki into kp into s, right? That means 1 plus 1 by st, where t is equals to ki into kp. Okay, if I simplify this equation, numerator also you are having 1 s, denominator is also having 1 s, right? That means it decreases, because of this pole, it decreases steady state error without affecting stability. Okay, that is the advantages of PI controller. Okay, proportional plus integral controller. Okay, because of this PI controller, what happened here, type is increases, right? When type is increases, steady state error is reduces. When this error is reduces, bandwidth of the system is bandwidth is reduces, and bandwidth and rise time is having inverse relation, that is TR is equals to 0.35 by bandwidth, right? When bandwidth is less, rise time is more. Okay, it improves damping ratio. When damping ratio improves means MP is reduces. Damping ratio is nothing but zeta, right? Okay, but in case of PI controller, transient response is low or slow. Okay, next coming to PD controller, that is Kp plus Kd into S. That means here same point again, reverse, right? PI, it is reverse to PI. That means here it increases the stability without affecting the steady state error. Okay, hence here it increases bandwidth, hence rise time is reduces and settling time is also reduces. Okay, whereas in case of PD controller, transient response is improved. Because of this point, it improves gain margin, phase margin and resonant frequency in frequency response analysis. Okay, next PID. Okay, it is having a partial advantages of PI controller and PD controller. That means it used to improve the stability as well as reduce the steady state error. Okay, that is about controllers. Okay, next coming to compensators. Okay, first one is lag compensator. Okay, this is the schematic diagram of lag compensator. Here Vi is input voltage, V0 is output voltage. Okay, now see here from this equation, the open loop transfer function GC is represented by alpha into 1 plus ST by 1 plus alpha into ST, where alpha is equals to R1 plus R2 divided by R2. Okay, where time constant tau is equals to R2 into C. Time constant will be R2 into C, where phase angle phi is equals to sin inverse 1 minus alpha by 1 plus alpha. Okay, see here in this lag compensator, this alpha value is greater than 1, then only these formulas will be applicable. Okay, in this lag compensator, if I draw a pole 0 plot, first it is pole is started, after that 0 is started. That means pole is nearer to the origin, then it is a lag compensator. If 0 is nearer to the origin, then it is a lead compensator. See here, lag compensator is having output side, it is having a series combination of RC. Okay, whereas lead compensator is having a parallel combination of resistor and capacitor. Okay, here the open loop gain G of S is 1 plus ST by 1 plus beta into ST, where beta is equals to here R1 by R1 plus R2, where time constant T is equals to R1 into C. Here beta value is less than 1. Okay, phase angle will be phi m is equals to sin inverse 1 minus beta by 1 plus beta. Okay, next these points will be same as here. PI controller points are applicable for lag compensator. Okay, for lead compensator, PD controller points are applicable. Bandwidth increases, rise time reduces, stability is improved, phase margin, gain margin is improved, right? Here also bandwidth reduces, rise time is improved, ESS is improved. That is same as PI. It is same as PD controller. Okay, next see here, like these questions you may get direct question. Okay, he is given figure like this, determine which compensator it is. Okay, for this type of figures you need to always proceed from right hand side to left hand side. Now see here, series combination of RC is having for which one? Lag compensator. Okay, parallel combination of R and C is for lead compensator. That means first my right hand side series combination is present, right? That means lag. After that parallel combination lead. That is a lag lead compensator. Okay, next similarly here. First here parallel combination is present, right? That is lead. Next series combination is present, right? Lag. Then the given compensator is lead lag compensator. Okay, from these two topics you may get problems. Okay, you can solve problems on this transfer function. Okay, thank you all.